The development of supersonic flight on American soil is a fascinating and complex subject, driven by technological ambition, strategic military interests, environmental concerns, and market demand for faster air travel. Supersonic flight refers to aircraft traveling faster than the speed of sound, defined as Mach 1, approximately 767 miles per hour at sea level. While the Concorde, a supersonic jet developed by the British and French, once served commercial routes, its retirement in 2003 marked the end of supersonic airliners. Now, the U.S. is at the forefront of reviving and advancing this technology for both military and commercial applications. In the commercial sector, several companies are racing to develop next-generation supersonic jets. Among them, Boom Supersonic, headquartered in Denver, Colorado, is perhaps the most prominent. Boom's Overture jet promises to deliver supersonic travel to passengers in the near future. Blake Scholl, the founder and CEO of Boom, has frequently emphasized that his vision is to make the world more accessible through faster travel times. He has described how advancements in materials, aerodynamics, and engine technology now allow supersonic jets to be more economically viable and environmentally friendly than the Concorde ever was. In a 2019 interview with CNBC, Scholl highlighted that Boom's aircraft will fly on 100% sustainable aviation fuel, SAF, a critical factor in making supersonic flight sustainable in the long term. The military's interest in supersonic and hypersonic technologies also plays a crucial role in this resurgence. Lockheed Martin and Northrop Grumman are leading American defense contractors pushing the boundaries of speed for military aircraft. The State Route 72, Lockheed's hypersonic successor to the legendary State Route 71 Blackbird, is a key example of the U.S. military's commitment to maintaining air dominance through speed. The State Route 72, still under development, is projected to reach speeds of Mach 6, making it a significant leap beyond traditional supersonic speeds. Interviews with Lockheed Martin's leadership reveal that the primary driver for such aircraft is the need for rapid intelligence gathering and strike capabilities, as hypersonic speeds would allow these planes to evade detection and hit targets faster than any current military aircraft. At the heart of the drive to develop supersonic flights in America is also a renewed interest in reducing the notorious sonic boom. The sonic boom, a loud noise created when an aircraft exceeds the speed of sound, has long been a regulatory barrier to supersonic flight over land. NASA's X-59K SST, Quiet Supersonic Transport project, developed in collaboration with Lockheed Martin, seeks to demonstrate that supersonic flight can be quieter. This is essential for making supersonic travel viable over populated areas without disturbing people on the ground. NASA has shared in various interviews how public acceptance of the technology is key to changing FAA regulations that currently restrict supersonic flight over land. In a 2020 interview, Peter Cohen, NASA's Supersonic Technology Project Manager, emphasized that reducing the sonic boom to something more akin to a sonic thump could revolutionize the industry. While military needs and environmental considerations are key, market demand for faster air travel is the biggest commercial driver behind these developments. Long international flights that can stretch to 12-16 hours today could be cut in half with supersonic technology. United Airlines has already made a commitment to purchase 15 of Boom's Overture jets, signaling that the airline industry sees potential in supersonic flights. In an interview with CNBC, United's Chief Executive Officer, Scott Kirby, noted that customers are increasingly demanding speed and efficiency, and the ability to reduce transoceanic flight times significantly is a game-changer for global travel. The goal is to make supersonic flights economically viable, unlike the Concorde, which was expensive to operate and had high ticket prices. In addition to Boom, other companies are exploring the potential for supersonic and hypersonic flight. Hermeus, an Atlanta-based startup, is working on developing a hypersonic jet capable of flying at Mach 5. This jet, aimed primarily at military customers, could also serve the commercial sector in the future. Hermeus leadership has frequently stated that their goal is to push the limits of speed to create flights that can cross the Atlantic in under 2 hours. They are working closely with the U.S. Air Force to make hypersonic air travel a reality. Their vision is to create a platform that serves both military applications and eventually transforms commercial air travel, bringing about a new era of high-speed, long-distance transportation. The American government is also playing a supportive role in this development. The Federal Aviation Administration, FAA, and the National Aeronautics and Space Administration, NASA, are collaborating with industry leaders to ensure that supersonic jets can meet the necessary safety and environmental standards. One significant hurdle has been developing engines that can perform at supersonic speeds without excessive fuel consumption or environmental damage. In recent interviews, experts from NASA have spoken about the potential of blending new engine technologies with sustainable aviation fuels, SAF, to make supersonic jets greener and more efficient. The collaboration between public and private sectors is seen as essential in making these advanced aircraft a reality. Moreover, there is growing public interest in the potential for supersonic travel, especially as the technology becomes more environmentally friendly. With the increasing focus on climate change, public opinion has shifted towards sustainable technologies, and supersonic flight must adapt accordingly. Boom Supersonic's commitment to using sustainable aviation fuel has been a major selling point in its public communications. In a 2021 interview, Blake Scholl emphasized that Boom's Overture would not only be fast but also sustainable, aiming for net zero carbon emissions. This approach is critical for winning over both regulators and the public, as environmental concerns remain high on the global agenda. As more companies enter the field, the competition to develop supersonic and hypersonic aircraft has intensified. Spike Aerospace, a Boston-based company, is developing the S-512, a supersonic business jet. The S-512 promises to be quieter than the Concorde, with a windowless design that improves aerodynamic efficiency. In interviews, Spike's leadership has emphasized the luxury appeal of their aircraft, noting that their target market includes high-net-worth individuals and corporations. While commercial airliners like Boom focus on larger passenger markets, Spike is tapping into the lucrative business jet segment. Another American player in the supersonic race is Exosonic, a California-based startup developing a low-boom supersonic airliner. Exosonic has gained attention for its focus on reducing the environmental and noise impact of supersonic travel. In interviews, Exosonic's CEO, Norris Tai, has spoken about the importance of low-boom technology in making supersonic travel feasible for commercial markets, particularly overland routes. Exosonic is also working with the U.S. military on a supersonic executive transport aircraft, which could eventually lead to commercial applications. Tai has often pointed out that the U.S. military's interest in supersonic travel will help fund research that could later benefit civilian aviation. In addition to these commercial developments, the U.S. Air Force is heavily invested in hypersonic technology for military purposes. Hypersonic flight, which refers to speeds above Mach 5, is seen as critical for the future of warfare. Hypersonic missiles and aircraft are designed to outmaneuver enemy defenses and deliver strikes at unprecedented speeds. In interviews with defense experts, there is widespread agreement that whoever masters hypersonic flight first will gain a significant strategic advantage. The U.S. military has several programs in development, including the Hypersonic Air-Breathing Weapon Concept, HAWC, and the Tactical Boost Glide, TBG, program, both of which are aimed at creating weapons and aircraft capable of traveling at hypersonic speeds. Despite the excitement around supersonic and hypersonic technologies, there are significant challenges that developers must overcome. One of the biggest challenges is creating engines that can operate efficiently at supersonic speeds without excessive fuel consumption. Additionally, the cost of developing and certifying supersonic aircraft is immense, requiring significant investment from both private companies and government agencies. In various interviews, industry leaders have acknowledged the need for continued innovation in materials, aerodynamics, and engine technology to make supersonic flight commercially viable. Another challenge is regulatory approval. Supersonic aircraft must meet stringent noise and emissions standards set by the FAA and international regulatory bodies. In recent years, the FAA has shown a willingness to revisit regulations governing supersonic flight. In interviews, FAA officials have stated that they are working closely with companies like Boom and Spike to ensure that supersonic jets meet the necessary standards without compromising safety or environmental protection. However, changes to these regulations will likely take time, as the FAA must balance the benefits of faster travel with concerns about noise pollution and environmental impact. The economic viability of supersonic flights is also a subject of debate. While companies like Boom are optimistic that their jets will be cost-effective, critics argue that supersonic flights may remain a luxury service for the wealthy. The Concorde, which operated from 1976 to 2003, was ultimately grounded due to high operating costs and low demand, and some question whether new supersonic jets will face similar challenges. In interviews, analysts have pointed out that the key to success will be lowering costs through advancements in technology and increased efficiency, as well as ensuring that tickets are affordable enough to attract a broader customer base. Despite these hurdles, there is a sense of optimism among developers and industry leaders. The U.S. has a long history of pushing the boundaries of aviation technology, from the Wright brothers' first flight to the Apollo missions and beyond. Supersonic and hypersonic flight represent the next frontier in this long tradition of innovation. American companies are at the forefront of this effort, leveraging advances in technology, government support, and market demand to bring supersonic flight back to the skies. In the coming decade, the U.S. is likely to see the return of supersonic commercial flights and the deployment of hypersonic military aircraft. The combination of private sector innovation, government investment, and growing consumer demand for faster, more efficient travel suggests that supersonic flight will play a major role in the future of aviation. Whether for commercial airliners, business jets, or military applications, the U.S. is poised to lead the world in the development of high-speed air travel, once again pushing the limits of what is possible in aviation.